Okay, so the problem is a hummingbird 3.4 meters above the ground flies 1.2 meters along a straight line path. Upon spotting a flower below, the hummingbird drops directly downward 1.4 meters to hover in front of the flower. What is the hummingbird's displacement, total displacement? Okay, so here are the equations. This is of course the Pythagorean theorem. Delta x squared plus delta y squared equals displacement squared. And this is the equation to find the angle of this right here, which is which equals theta equals tangent, inverse tangent of delta y over delta x. Okay, so first we wanna write down what all the data is. So the first data we write down is above ground equals 3.4 meters, and flies across 1.2 meters, and flies down negative 1.4 meters. Okay, so now we draw a quick diagram. So the hummingbird starts at point A and moves to the left or right. It just says across 1.2 meters, and it moves to point B, and then it flies down negative 1.4 meters to point C, and the displacement is AC. So we need to find this, and the way we can find this is through the Pythagorean theorem. Okay, so we want to find the displacement squared. So what we do is to use this equation: x squared plus y squared equals displacement squared. We substitute these values in, so we get 1.2 squared plus negative 1.4 squared equals displacement squared. Then you square these two numbers, and then you get 1.44 plus 1.96 equals displacement squared. This eventually, if you add these two up, you get 3.4 equals displacement squared. To get d by itself, you want to find the square root of both, and then you get 1.8439 equals d. Then you have to remember about sig figs, and as you can tell, they're going to two places, so you go two places right here, which is 1.8 equals d. Therefore, the hummingbird's total displacement is 1.8 meters. However, we're not done with this problem. We need to find the angle of theta right here. In order to do that, you need to use this equation: theta equals inverse tangent of delta y over delta x. Then we use some substitution again, like this, and then you get theta equals inverse tangent of negative 1.4 over 1.2. You plug this all into your calculator. You eventually get negative 49.4 degrees. Then you have to use sig figs like we did here, and then you get negative 49 degrees. So therefore, the angle of displacement is 49 degrees below the horizontal. Doing chapter 3, practice scene number 3, known as the clown problem. The problem is, during a rodeo, a clown runs 8.0 meters north, turns 55 degrees north of east, then runs 3.5 meters. Then after waiting for the bull to come near, the clown turns due east and runs 5.0 meters to exit the arena. What is the clown's total displacement? Okay, so what we want to do first is set down the equation that we must need for this problem. It is the Pythagorean theorem, and sine, cosine, and inverse tangent. You can see these equations right here. Now, we want to put down all the data we need. So, he runs 8.0 meters, runs north, that's the first action he takes. 55 degrees north of east, turn, and that's the second action he takes. 3.5 meters equals how much he runs, is the third action he takes, and 5.0 meters, and he runs east, that's the fourth action he takes. Okay, so now we must draw a diagram so we know what's happening in the problem. He runs 8.0 meters north, then he takes a 55-degree turn right here, as you can tell. Then he takes 3.5 meters this way after this turn, and then he runs 5.0 meters east right here. So the problem is asking for is this displacement right here. In order to solve that, we must put this problem into three parts. So let's start with the first part. So right now, we want to find all the data for this small triangle right here. So we must find theta right here. So you do 90 minus 55 equals theta. Simplify that out and do that. And then you find the sine of this. So you can find the opposite. And after doing the whole thing, you get 2.007517 meters equals opposite. Now we move on to part 2, which is hypotenuse squared equals, this is the edited version of the Pythagorean theorem. So you do hypotenuse squared minus opposite equals adjacent squared. You want to plug these things into the equation. and then you eventually get 8.2198734 equals adjacent squared. You want to find a square on both sides, and you get 2.86703 equals adjacent. On to the next part. So now what we want to do is find this whole length right here and this whole length right here, so you can find displacement through Pythagorean theorem. So what we want to do is add adjacent to 8.0, so we can find y, which is right here, and add opposite to 5.0 meters, so we can find this length right here. And then you get these two values as those. So what you want to do is x squared plus y squared equals d squared, another Pythagorean theorem equation. You want to simplify that out, plug it in, simplify it out. Then you eventually get 12.93 equals displacement. You're going to, of course, use sig figs, then you get 13 equals displacement. On to part 4. This part 4 will be identifying theta 3 right here. So what we first need to do is find theta 2. So we want to use this equation, tangent -1, tangent inverse tangent. You want to plug these x and y in, so you can get theta 2. You want to plug this into your calculator. You get this value right here. You want to subtract 90 minus this value right here, so you can find theta 3 right here. And you want to keep on simplifying it until you get 57.184 as theta 3. And use sig figs, of course, and you get 57 equals theta 3. So the final answer is displacement of the clown is 13 meters, 57 degrees north of east.